Momentum. The definition of momentum, then how momentum changes and relate it to impulse, some graphs of impulse, then the conservation of momentum and different types of collisions, starting with inelastic collisions and explosions, elastic collisions, collisions in two dimensions, and wrapping it up with center of mass. Momentum. Newton's first law states that objects remain in motion with a constant velocity unless acted upon by a force. In our experience, when two objects of different masses travel with the same speed, the one with more mass is harder to stop. When objects of equal masses travel with different speeds, the faster one is harder to stop. Momentum, and its symbol is P here, is defined to account for these observations. Momentum is equal to mass times velocity. The momentum of a single object is the product of its mass and its velocity. Momentum, like force, acceleration, velocity, and displacement, is a vector. Momentum is in the same direction as the velocity, as mass is a scalar. So if this velocity is to the right, the momentum is also to the right. Mass is a scalar, so it does not change the direction. The unit for momentum is the product of the units in the formula. So mass is kilograms, velocity meters per second, so we say kilogram meters per second. Vectors can be written with an arrow above the quantity or in bold type. What is the momentum of a 3,000 kilogram truck traveling at 15 meters per second? Answer is on the next slide. We write our givens right here. And as no direction is given here, we're just calculating the magnitude of the momentum. So we have our equation here, mv, substitute in the mass and the volume, and we get 45,000 kilogram meters per second. A 1,500 kilogram ferry boat has a momentum of 30,000 kilogram meters per second. What is the velocity of the ferry boat? We write our givens. And what are we trying to solve for? Velocity. So we start with the momentum equation, isolate the velocity by dividing both sides by the mass, substituting in our variables here, and we get 20 meters per second. So this kilogram cancels out there, so the units check out. A car travels at a constant velocity of 24 meters per second and has a momentum of 28,800 kilogram meters per second. What is the mass of the car? Start by writing out the givens. And this is a momentum problem, so here's our equation. But we want to find the mass. So we divide both sides by velocity, and get mass is momentum over velocity. Here's our momentum, here's our velocity. And meters per second cancels out, so we get the right units, kilograms. And the answer is 1,200 kilograms. If a system contains more than one object, the total momentum is the vector sum of the momenta of those objects. So here's our equation. Total momentum is the sum of each individual momenta. So that's P1 plus P2 plus P3 plus however many other objects you have. And then substitute M1 V1 in for P1, M2 V2 for P2, etc. To determine the total momentum of a system, choose a direction considered to be positive, assign positive values to momenta in that direction, then assign negative values to momenta in the opposite direction. Add the momenta to get total momentum. So we're taking to the right here as positive and the left as negative. So we're taking into account the vector nature of momentum. Determine the momentum of a system of two objects. M1 with a mass of 6 kilograms and a velocity of 13 meters per second towards the east, and M2 with a mass of 14 kilograms and a velocity of 7 meters per second towards the west. We'll choose east as positive, which means west will be negative. So down here, maybe you've noticed that the velocity is in bold because we turn it into a vector here. Since V1 is to the right, that will be a positive 13 meters per second. Since V2 is to the left, that's a negative 7 meters per second. We write our givens, and the velocity of the first object is to the east, so that's a positive 13 meters per second. The second object is to the west, so that's a negative 7 meters per second. Our total momentum of the system is the sum of the individual momenta. So here's the first one. There's our positive 13 meters per second. And here's our negative 7 meters per second for the second object. We add these numbers together, and we get the total momentum is minus 20 kilogram meters per second.